All right, hopefully you have your notes ready to go. We're going to take some more notes here today, so if you haven't done that, go ahead and hit pause, come back to this. We are in section 5.2. This is in your Module 5 note packet. Let's go ahead and get started. So this is a review of Integrated 1 material. I think you'll find that it's pretty simple, pretty basic stuff, but some things that we definitely need to go over. So what exactly is a relation? A relation is a set of ordered pairs that connects inputs and outputs. For example, this is a relation. It might be a function, we don't know, y equals 3x. And I can relate inputs and outputs because I can plug in an x equals 5. So what I would do is I would input the 5. So 3 times 5 is 15, and that would give me 3 times 5, 15, y, my answer that I was looking for. So 5 and 15 are related by plugging it in. I plug in the 5 and I get 15. Okay, so I've got some sort of relation there, inputs and outputs. Now domain is going to be the set of x values, or the inputs. And range is the set of y's, that's the outputs. Okay, so we got inputs and outputs that we're looking at there. Okay. Now, a function is a relation where each input is matched up with exactly one output. So each x has only one y. Okay, and we'll get into that. It's kind of each guy is taking one girl to the dance. It's going to function quite well. Okay, now a one-to-one function, no input is used more than once. No y is repeated. Okay, so we'll look at that. Like I said, my example is kind of, guys and girls going to the dance. And many-to-one function, one output or more is used more than once. And again, I'll get into all these examples here for you so you see it very clearly. Okay, now an inverse function is where inputs, those are your x's, are switched with outputs. Those are your y's. So your x's and y's are going to be switched. Okay. Now, if the inverse of a function is also a function, you're going to want to use inverse notation. Now, what is inverse notation? You write this f to the negative first of x. Okay, you're going to see that a little bit along the way. So that might not be something you've seen much of yet. That's probably a new thing to you. If the inverse is not a function, it's only a relation. We'll get into that in just a second. The inverse of a function is the reflection, and we don't do a lot with this, but a little bit of material here for you. It's the reflection across the line y equals x. Okay, and you did reflections across y equals x in Integrated 1 as well. So let's get into a few examples just so you can kind of see some different ways that functions are laid out, and then see, okay, yeah, I have seen a few of these things along the way. Okay, so here we go. First example is going to be if I have a table. Okay, so what does that look like? You've seen tables before. We're talking about this kind of table. An input-output table. Some teachers call them an XY T-chart. Depends on what you want to call it. Okay, and let's say that I have, and I know from the function that I have, the equation that I have, 1 gives me 3 when I plug it in, 2 gives me 5, and 3 gives me 7. I'm just, making up these numbers. There's nothing that we actually did to get that. This is the example. Now, one thing to note here is that if it is a function, oftentimes you'll see instead of y, you'll see f of x. F of x and y are the same thing. Okay, and you've seen that before, and you'll see that kind of along the way here. So first thing we want to look at is this a function? Does each x have only one y? 1 is taking 3 to the dance. It only has one answer. 2 only has one answer. 3 only has one answer. Okay? So is it a function? Yes, it is a function. Because again, x's are only taking one girl to the dance. And again, I'll explain to you what that means in just a second when we see some other ones. Now, second is domain and range. We want to find that. Okay, I'm giving you topics that you're going to need to know. So domain and range. You put these into what I call squiggly brackets. There's probably a name for those. I don't know what it is. Little squiggly bracket. And for domain, you list all your x's, 1, 2, and 3. And then you close the squiggly bracket. We do a lot with domain and range versus discrete versus continuous. We've got a lot of things we need to look at there, and we will. Range is all your y's. So 3, 5, and 7 is your range. And again, you learned this in Integrated 1. This should be review. Okay, so that's the second thing I want to answer. Now, the third thing I want to answer is this 1-to-1 or is it many-to-1? Okay, now to be 1-to-1, no output is used more than once, meaning there's no y that's repeated. Are any of the y's repeated? No, they're not repeated. If it is a function and no y's are repeated, we can say that it is a 1-to-1 function. Again, a lot of this right now is just some vocabulary to get you going. Now, if I want the inverse of this, so this table, I want to find the inverse. Okay, very easy to do. It just says up above, if you read the note, is all you have to do is switch inputs and outputs. So you're just going to trade x's and y's. So 3 is 1, 5 is 2, 7 is 3. Again, I'm just switching x's and y's. Okay? So there is my inverse. And now we're going to check to see if it is a function. So looking at this table, do we have a function? Well, does each x have only one y answer? 3 has one answer, it's 1. 5 has one answer, it's 2. 7 has one answer, it's 3. So yes, it is a function. Okay, number 2, what's your domain and range? Domain is going to be all the x's, 3, 5, and 7. And then your range is going to be all your y's, 1, 2, and 3. Okay, so there is your domain and range. Third thing we want to look at is this 1-to-1 or many-to-1? Okay, so we're looking at, again, for 1-to-1, no output is used more than once. Are any of the y's used more than once? No. We've got them paired up, 1 to 1 to 1. Okay, so this is, it's 1-to-1 again. Again, I'll get to the other types in just a second. All right, so next thing I want to look at is a mapping. So example 2, mappings. What does that look like? Okay, you've seen mappings before. This is the way they show a mapping. There are these little bubbles. They'll have like 2, 3, and 4 like this. And then another little bubble where it goes 4, 5. Okay, numbers again are random. 2 goes to 4, I'm going to have. 3 goes to 4, and 4 goes to 5. Okay, and again, I want to answer the same questions. Now, it may not be labeled, but your first bubble on the left is your x's. The bubble on the right is your y's. Okay, so is this a function? Number 1. Is it yes or no? Well, how many answers does 2 have? It has 1. It is 4. How many answers does 3 have? 1. It is 4. How many answers does 4 have? 1. It is 5. So yes, it is a function. Okay, yes, it is a function. Okay, domain is all the x's, range is all the y's. So the domain is going to be 2, 3, and 4. The range is going to be all the y's, 4, and 5. Okay. Now, lastly, is it 1-to-1 or many-to-1? Okay, 1-to-1 or many-to-1. Well, again, is each guy taking one girl to the dance? Uh-oh. 2 is taking 4, and 3 is taking 4. This would be a problem. This is a many-to-1 function. You have many guys taking the same girl, which is probably, again, going to be a problem. 2 is trying to take 4, and 3 is trying to take 4. 4 is fine. He's got 1, and it's 1-to-1 there. But as soon as you've got 2 guys repeating the same y, 4 and 4 here, then you got a problem. Okay, now, for your inverse, so we're just going to switch x and y. So in the first bubble, you're going to have 4 and 5. In the second bubble, you're going to have 2, 3, and 4. Okay, and what's going to happen is 4 is going to go to 2, and 4 is going to go to 3, and then 5 is going to go to 4. That's the way the function is set up when you switch x and y. Okay. Now, is this a function? Whoops, number 1 here. Is it a function? The answer here is no, not a function. Why not? Because again, 4 has 2 different answers. 4 is 2, and then 4 is 3. That is not possible, so it's not a function. And since it's not a function, generally you don't state domain and range, and you generally don't state if it's one-to-one or many-to-one because it needs to be a function. Okay, now, third example here, and then this is going to close out this video. Example 3 is going to be with points. So if I have a set of points, let's say I tell you that f of x, and I'm actually telling you this is a function when I use f of x. F of x is the set of points 1, 2, 2, 2, 3, 2. Okay, so question number 1, is this a function? Well, 1 has one answer, it's 2. 2 has one answer, it's 2. 3 has one answer, it's 2. Each x has only one answer. So yes, it is a function. Now, what's the domain and what's the range? The domain is 1, 2, and 3. Those are all your x's, 1, 2, and 3. What is your range? Your range is just 2. You don't write repeats. Every one of them is 2. You don't write repeats. Now again, 1 has one answer, 2 has one answer, 3 has one answer. You might be kind of mind-boggled by that yes, it is a function. But again, it only has one answer. Okay. In class, I'm going to talk a little bit about a soda machine, and that'll help you kind of understand the function part a little bit better, I think. Okay. Now, third question, is it one-to-one or many-to-one? I got 1 trying to take 2 to the dance, 2 trying to take 2, 3 trying to take 2. That is a many-to-one situation. Many-to-one. Okay, many-to-one function. Now, what does the inverse look like? So the inverse is going to be where I switch x and y. So you just take the set of points, and you're going to switch x and y. So 2, 1 instead of 1, 2 now. Just switch x and y. 2, 2, and then 2, 3. We're taking these points, and we're switching x and y. Number 1, is it a function? Well, how many answers does 2 have? 2 has 3 different answers. When I say 2 is 1, and then 2 is 2, and 2 is 3, this makes it not a function. Okay, sometimes the inverse is not a function, but that's not always the case. If you look at the first one, it still was a function, so don't start thinking the inverse is not. Okay? All right, I'm going to pause the video here, take a little break, come back, and we'll do a little bit more on the next page. Okay? All right, see you in a bit.